Suppose that f of x equals 4x squared plus 4x. Find. We're going to jump down here to C. We want to find tangent lines where x equals 2 and x equals 3. So the first thing we do is find the derivative. Already did that up here, which is very nice. So we have f of x equals 4x squared plus 4x. Derivative, using the power rule, is 8x plus 4. Okay? So for the tangent line is going to be of the form y minus y1 equals m, which is the slope, x minus x1, where y and y1 are just y1 and x1 are just points on this this graph. So we're going to start by finding m. So m at 2 would be f prime of 2. Change colors just to maintain my attention. Whoop. F prime of 2 is going to be 8 times 2 plus 4. It looks like a 9. It's supposed to be a 4. Don't know why I put an extra parenthesis there. Not needed. 16 plus 4, which equals 20. Excellent. So from here then, we're going to we need to find f of 2. So we know x will be 2, because that's kind of assumed here. X equals 2. We need to find f of 2, because we're just going to basically be like, well, this function is this of x, which is basically y, which it basically kind of sort of is. So we do 4 times 2 squared plus 4 times 2, which equals 4 times 4 plus 8, which equals 16 plus 8, which is 24. Plugging this into our equation, right up here, we have y minus 24, excellent, 24, equals m, which is the slope, which you already know is 20, times x minus x1. And x1 we know is 2, because that's kind of assumed. So simplifying this, we have 20x minus 40. Rearranging this, we have y equals 20x minus 40 plus 24, which gives us 20x minus 16. And so our answer for part C, I guess the first part of part C would be y equals 2x minus 16. And then for for x equals 3, same thing. We will use the general idea of y minus y1 equals mx minus x1, parentheses. We'll solve for the slope, m, and we'll also solve for f of 3. So you basically plug 3 in for x. Same idea. All right, jumping on to number D, letter D, number D. We'll go to the fourth part of the fourth question. I guess that's actually the sixth question. 1, 2, 3, 4, 5, 6. Question 6, letter D. List all values of x where the tangent line is horizontal. Okay, so this gets kind of the idea of maximum and minimums. So we look at this graph here. It's going to be kind of something sort of like that, maybe. Because we have a 4x squared, and this is going to kind of, 4x is kind of like a line. It's going to have this kind of feel to it. So we're going to assume that there's some sort of minimum here. What we're looking for is that minimum. And if you look at this from an intuitive point of view, it's like, all right, list all values of x where the tangent line is horizontal. So we're like, all right, horizontal tangent line, like that. That implies that the slope of that tangent line will be 0, as opposed to the slope of a vertical tangent line. Vertical tangent line is where m would equal infinity. So this one, m equals 0. So m, which is slope, so we'll do f prime of x equals, we already found out what that was, 8x plus 4. F prime of x equals 8x plus 4. And to find the horizontal tangent lines, we're going to set equal to 0. So we have 8x equals negative 4. So set equals 0, move the 4 over there. X equals negative 4 over 8, which is similar to negative 1/2. So we want to find the horizontal tangent line, that's negative 1/2. Yep, and I'm good with that. So values, x equals negative 1/2. Check, go, Done. Excellent. Hope that helped. I will see you next time.